at application of calculus in kinematics. Kinematics deals with the kinematics deals with the speed of the bodies, the way they move when forces are applied. So we are going to consider that the distance covered by a particle at time t is given by, for instance, t 2t power 4 plus 3t power 3 plus 4t squared plus 6t plus 1. So this is the displacement of a particle, which is given by this at time t. So we are to find a the speed of the particle at t is equal to 0, and b the acceleration of the particle at t is equal to 1. So to do that, a solution so to do that, we know that velocity is given by derivative of displacement with time. So we are going to differentiate this one. So you have t power 4 differentiated will give us 8t power 3 plus 3t cubic differentiated will give us 9t squared plus 4t squared will give us 8t plus 6. So that is the derivative. Then velocity v at t is equal to 0 will be given by is equal to 8 0 power 3 plus 9 0 squared plus 8 0 plus 6 which is equal to 6 meters per second. So that is how you can apply calculus to determine the velocity of our body at t is equal to 0. So number B, acceleration is given by d of v, derivative of velocity with respect to t, which is equal to, so we differentiate this. So 8t cubic differentiated will give us 24t squared plus 9t squared differentiated will give us 18t plus 8t differentiated will give us 8. 6 differentiated will give us 0. So acceleration A at t is equal to 1. Part B we are told to get the acceleration A at t is equal to 1 will be given by is equal to 24 1 squared plus 18 1 plus 8. So that is what we do. So 1 squared is 1, that is 24 times 1 is 24 plus 18 times 1 is 18 plus 8. So you have 8 plus 8, which is 16, plus 4, 20. 20 carry 2, 3, 5. 54 meters per square second. So that will be our acceleration. That will be our acceleration. So simply what you do when you are given the displacement, to get the velocity, differentiate the displacement, because velocity is equal to rate of change of displacement with the time. So that is the rule we are applying here, that velocity is equal to change in displacement over change in time, the average velocity, of course. That is the principle we are applying here. For the acceleration, the principle we are applying is this, that acceleration, average acceleration, is given by change in velocity divided by change in time, whereby we are using the average velocity and the average displacement. So that is what you do. So something else to note is that at t is equal to 0 seconds, this fact they are important, displacement is equal to 0. For a body which is moving uniformly on a straight line is equal to 0 meters. Something else, these are key things to note here. Something else to note is that acceleration is equal to 0 when we have velocity, when velocity is equal to constant. So when velocity is constant, acceleration is 0, because acceleration is given by v over u divided by t, where v is the initial velocity, u is the v is the final velocity, u is the initial velocity, t is the time. Since if you have u is equal to v, it implies that a is equal to u minus u over t, which is equal to 0 over t. Any 0 divided by any number is 0. So that is why acceleration is equal to 0 when velocity is equal to constant. So that point is important. Another note here we need to note is that velocity v is equal to maximum velocity is maximum when acceleration is 0 meters per square second. So that is when you get a maximum velocity. Another point to note here is that the body is at rest. The body is at rest when t is equal to 0 seconds. So if you are told the body is at rest, then you should know that if you are told the body is at rest, then that tells you that the time for that particular body is equal to 0. So when the body is at rest, then that tells you that the body is equal to 0. Maybe I give you another example. So given that s is equal to 1 over 3 t cubic plus t squared minus 3t, here you are told to find the velocity, find t, when you find t when v is equal to 0. So first of all, to get v will be given by v is equal to ds over dt. So we differentiate this. This one will give us 3 over 3 t squared plus 2t minus 3. Of course, this is the same as 3 and 3 will cancel, and you are going to have t squared plus 2t minus 3 minus 3. So you ask yourself, what are the two numbers which you multiply, you get 3, and when you want, you get so our product here is -3. Our sum is 2. The two numbers which you multiply, and when you want, you get 2. So these two numbers are 3 and -1. Because 3 times -1 is -3. 3 plus 1 is that. So when v is equal to 0, so we equate this with the 0, the derivative. So we are going to have t squared. Instead of 2t, we replace with minus t plus 3t minus 3 is equal to 0. So we factor t here, t minus 1 plus 3 is common here, t minus 1, which is equal to 0. So t minus 1 is common, so we have t plus 3 into bracket t minus 1, which is equal to 0. So at this case, we have two possibilities. Either t plus 3 is equal to 0, so t plus 3 is equal to 0, or t minus 1 is equal to 0. So t is equal to -3 seconds, or t is equal to 1 second. Now, time cannot be negative. So to answer this question, whereby we are to find t when v is equal to 0. So our time t is equal to 1 second. Note that time cannot be negative. So the time at which velocity is 0 is t is equal to 1, which you can substitute here, and you are going to see that is the value. From the same, of course, we can get acceleration. A will be given by dv over dt. So this is our v. So we differentiate that, and we have to find a is equal to 2t plus 2. So that is our acceleration. So at t is equal to 1, our a will be given by 2 times 1, which is 2, plus 2, which is equal to 4 meters per square second. So that's how we apply calculus to solve the kinematic equation. So I hope this video has been helpful to you, and I request you to consider subscribing to this video so that you won't miss a single study which I upload now and then. Also feel free to suggest any area of your interest, and then I will be pleased to tackle it on your behalf. So always remember this fact that at t is equal to 0, displacement is 0 meters. acceleration is 0 when velocity is constant. Because of this fact, velocity is given by rate of change of time, rate of change of velocity with the time. So that is the fact we are using. Also, then when we are told the body is at rest, know that the time is equal to 0. And know that velocity is maximum when acceleration is 0, because there is no change. There will be no change in acceleration. So those are the facts which you need to master. And that is the way you can easily make use of calculus in kinematics, basically in determining the rate of change of a particle. And the rate of change, we can get the average velocity and the average acceleration. Simply what you do to get the velocity from displacement, you differentiate displacement with respect to time. And to get the acceleration, you differentiate velocity with respect to time. In the other ones, to get the acceleration from displacement, S, differentiate it twice with respect to time. And then you are going to obtain your answer. So, bye bye. Let us meet next time as I continue teaching.